Hello, I'll solve this exercise in this video by given ABCD is a parallelogram. M and PQ are 4 points defined by the following. Part 1, it's required to show these relations. A, BN equal 1 over 3 AB. Using the converse of Chazel's rule, we may decompose vector Bn by using point A. Vector Bn equal Ba plus An. Vector Bn is vector Ba is the opposite of AB, so it's minus AB, plus using the given we may write An as 4 over 3AB. Like terms, minus 1 plus 4 over 3 equal 1 over 3. So vector Bn equal 1 over 3AB. Similarly, vector Cp can be proved that it's equal to third BC. How? By using the converse of Chazel's rule, we may decompose vector Bp, vector Cp equal 1 over 4 Bp. We may decompose vector Bp by using letter C, using converse of Chazel's. Vector Bp equal Bc plus Cp. Now separating, we get Cp minus to the other side 1 over 4 Cp equal 1 over 4 Bc. Like terms, 1 minus 1 over 4, 3 over 4 vector Cp is a quarter vector Bc. So vector Cp is 1 over 4 over 3 over 4 vector Bc. Compound the fraction, we get what's required. Last, we have to prove that vector dq is third vector cd. Here I started with vector dq. Since by given we have vector cq, so I decomposed vector dq by using letter C. So dq is dc plus cq. We have to write dq in terms of cd. That's why I wrote dc equal minus cd. And I used the given, I replaced CQ by minus 4QD. Similarly, separate DQ plus 4QD equal minus CD. Reduce, we get DQ equal third BC. So part A is proved. Next, we have to draw the figure and plot the points M and PQ. How to plot point M? We have vector AM by given equal minus third AD. AM and AD have same direction, opposite sense, since the scalar here is negative, and the magnitude of vector AM equal absolute value of minus 1 over 3, which is 1 over 3, multiplied by the magnitude of AD. Again, since AM equal minus third AD, so the AM and AD have same direction, opposite sense since the scalar is negative, and the magnitude of AM equal third the magnitude of AD. AD, its sense is downward, so AM should be upward, and the magnitude of AM is third the magnitude of AD. So here's point M. Next, I have to plot point N. Vector AN equal 4 over 3 vector AB. So AN and AB have same direction, same sense, and the magnitude of AN is 4 over 3 multiplied by the magnitude of AB. So AB, I measure it, multiply its length by 4 over 3, and I get point N. Same direction, same sense. Next, plot point P. Vector CP equal quarter vector BP. Here, the unknown point is found on the right and the left side. That's why it's easier to plot point P to use what we proved in part 1. So vector CP is third BC. Vector CP and BC have same direction, same sense, and the magnitude of CP is third the magnitude of BC. BC, CP. Last, to plot point Q, vector DQ. Similarly, I'll use what I proved in part 1. Vector DQ is third DC. So DQ equal third CD. So CD, DQ, same direction, same sense, and the magnitude is third that of CD. Surely by using the ruler, you find the length of CD and you divide it by 3. So here is point Q. And I'm done with part B. Next, we have to deduce. It means we should use the previous result, that MN equal to third AD plus 4 over 3 AB. In other words, I have to write MN as linear combination of vectors AD and vector AB. This is part C. What will I do here? I will decompose vector MN. I should use the given. So I may decompose vector MN by using vector MA plus, since I have no information, okay, MA plus AN. Vector MA can be replaced by minus third vector AD, and vector AN can be replaced by 4 over 3 vector AB. So I used the previous result to show that vector MN can be written as linear combination of AD and AB. Next, I have to write now MN as linear combination of BC and DC. So vector MN I have to write it as linear combination